All right, so let's move on to the next definition. Definite integrals. All right, so definite integrals goes like this. When you have a function and you only want to look at the function over a certain interval. Okay, so suppose looks like this: y equal to f of x, x, y, and then this is a, this is b. All right, so then the area under the curve y equal to f of x over the interval ab is given by the definite integral of this function from a to b. Okay, so by definition, this is obtained through taking the limit of Riemann sums. However, this is difficult to implement. So then we have a very, very important theorem called fundamental theorem of calculus. Okay, so this is saying that if you know there is a function which is an antiderivative of the integrand, i.e. the derivative of capital F is equal to the letter f. Okay, if you know this, then fundamental theorem calculus tells you, oh, then don't worry too much. This area under the curve y equal to f over the interval ab is nothing but this antiderivative at the b minus antiderivative at the a, and we use this notation, so this means f of b minus f of a. Okay, so this is a very powerful and very important in Calc 3. We have a similar theorem called the Fubini's theorem. That will help us to evaluate an integral that's hard to evaluate. Okay, all right, but this is for later, so you don't have to worry about what Fubini's theorem is. We're just talking about definite integrals and fundamental theorem calculus. Okay, so now just some quick examples. Let's say if I'd like to evaluate the definite integral from 0 to a half pi, then what do? I look for an antiderivative of this integrand. So antiderivative sign is equal to minus cosine. Antiderivative 2 is equal to 2x, and then 0 to a half pi, so I have minus cosine a half pi plus 2 times a half pi minus negative cosine 0 plus 2 times 0, just like that. Okay, cosine a half pi is equal to 0, so 0 plus pi minus cosine 0 is equal to 1, so negative 1 plus 2. So overall what I get is pi minus 1, like that.